So far in this series, we have had exposure to different kinds of preferences, substitutes, complements, goods, bads, and all that jazz. In this video, let's talk about well-behaved preferences. Now, what do we mean by well-behaved preferences? This is just a fancy way of saying that we will be focusing on a very specific type of preference, and we call that well-behaved preference. And we resort to that kind of a preference because that is easier to deal with as far as mathematical and microeconomic analysis is concerned. So let's understand what are the assumptions of well-behaved preferences. So essentially you have three assumptions. Now let me list them first. So first is more is always better. Second is averages are preferred to extremes. And the third is just an extension of the second. We strictly prefer the average to extremes. Let's go to each of them in detail. Let's say you have two bundles. Bundles meaning a set of goods. X1, Y1 and Z1. This is your bundle 1. Now what about the other bundle? X2, Y2, Z2. Now I tell you that X1 is greater than equal to X2, Y1 is greater than equal to Y2, Z1 is greater than equal to Z2, and an added information that X1 is also strictly greater than X2. Now I could have said X1 greater than X2 or just Y1 greater than Y2 or just Z1 greater than Z2. Now why I'm trying to give you this description? Because when I say more is better, I have to make one bundle strictly more than the other. So if I just say that this bundle has all the goods same in the same quantity as this bundle, I'm not creating more. To create more, I need to at least give one good in a larger quantity, and that is why this is the description of more. Now I will tell you, if this is the condition of more will be better, which means that let's say this is your bundle 1 and this is your bundle 2. I will always prefer bundle 1 to bundle 2. Now the reason is more is better. It's as simple as this. Now we also called this as monotonicity of preferences, or simply monotonous preferences. Now let's move to the next one. The second assumption for well-behaved preference is averages are preferred to extremes. What does this mean? Let's say you have two bundles, bundle 1 and bundle 2. And just for the sake of simplicity, we have just two goods. This will have X1 and Y1. This will have X2 and Y2. So these are our extremes, and let's also assume that these two bundles are on the same indifference curve, which means that you are indifferent between these two bundles. In that case, if I take a weighted average of these two guys, I will have a preferred bundle. Now what do I mean by an average? Let's say I take half of X1 and half of X2. This will be my new X, and I take half of Y1 and half of Y2. This will be my new Y. So this is going to be your new bundle, and averages are preferred to extremes. So B1, B2 are indifferent to each other, but this new bundle, B3 bundle, will essentially be preferred, I can say this symbol, to B1, B2. So essentially B3 is preferred to B1 and B2. Now what does this tell you about the shape of the indifference curve? So the first assumption which we built, more is better, has some kind of a relationship with averages to extremes assumption as well, because if we combine the first two, we will understand that we will have a convex kind of a preference structure, which means this kind of a structure. Now why do we have this kind of a convex kind of a structure? Now let's understand the first assumption. First assumption was more is better. So if more is better, and let's say I am at this point somewhere here, right? And if I move in this direction and then this direction, so essentially I'm moving somewhere in this direction, right? So in that sense, I'm decreasing both the goods. So I will be worse off because more is better. And if I move in this direction and this direction, it means I'm increasing both the goods, so I'll be better off. Which means that this direction will give you better off and this direction will give you worse off. So the only relation which you are left out is this direction, which means your indifference curve must be sloping downwards, because this is better, this is worse. So you have to have some kind of a direction in which you are neither better neither worse, you are indifferent. So downward sloping indifference curve, because of the first assumption, more is better. What about averages to extremes? So if I take, let's say, this point and this point, these two guys are on the same indifference curve, which means, let's say this is my B1 and this is my B2. So I am essentially indifferent between B1 and B2. But what about the average? Let's take an example of an average. So let me connect a line here and let's think of this as my average, right? Now the thing is, over here I have given half, but it's not really necessary. I could have given it small t 1 minus t, small t 1 minus t, because over here averages does not mean equal weights, it is weighted average. So I could also modify this to say weighted averages is preferred to extremes, right? So this guy over here is your B3. Let me write B3. So B3, you can see, is above than this indifference curve. Let me label this indifference curve like this. So this indifference curve is below to B3, and all the points on this line essentially are weighted averages of B2 and B1. So they are above this indifference curve. So all the points on this line will be preferred to this indifference curve, or they will lie on a higher indifference curve, right? So that is the idea of averages are preferred to extremes. Now, can we have some other kind of indifference curve which doesn't obey this averages to extreme assumption? Yes, definitely. Let's look at them as well. So what about I tell you that this is my indifference curve? In that case, if I connect 2 points over here, you can pretty well see that there are points which are above, there are points which are below. So this definitely is a non-convex indifference curve. Let's take another example. Another example could be just the opposite of this. Let's say I have this kind of an indifference curve. In that situation, you just have the opposite, meaning the entire line connecting the two bundles is below. So you can also say that this is your concave, this is convex, non-convex, this is concave. We will talk about more about convexity, concavity in mathematical economics lectures, but as of now, this is just to say that when you have to think about convex indifference curve, just think about this, that line connecting two bundles will always be above the indifference curve, that is your strictly convex, which is a good segue to the third assumption. The third assumption, I'll not write it over here because that's not important very much. The third assumption is we have strict convex preference. Now, what is strict convexity? This is an example of strict convexity. Now, what is a not so strict, or I should say just convexity? For that, I will just give you the example of substitutes. You remember substitutes has this kind of an indifference curve. So this is convex, but it is not strictly convex. So it is obeying the first two assumptions. More is better, averages to extremes, but it is not obeying the third assumption, which is averages are strictly preferred to extremes, not just preferred, strictly preferred. This is just preferred, this is strictly preferred. This is just convex, this is strictly convex. This is non-convex, this is concave. So I hope you understood the idea of well-behaved preferences. I hope you like this video. If yes, give it a thumbs up and do subscribe to this channel, because in this channel you can find content related to mathematics, economics, finance, data science and anything related to knowledge.